All right, so today we're going to talk about logarithms. And so does anybody know why do we do logarithms right after exponentials? No? Just because I get told to? Because L comes after E? So we do the E's first and then the L's? Because it's harder? Oh, this one's easier than, so we do the hard one first and then the easier? None of these are the reasons. Not because I want to either. Why? There we go. That one out of all of you. I'll take that as a win. All right. So it's the same thing. This is the inverse, right? So all I've done is switch the x and the y. So the exponential, it was either a growth or a decay, and it always went through what point? 0, 1, and it had an asymptote at 0, okay? So the log is just going to be the inverse of that, okay? So this is log base b of a equals x, log base b of a equals x. So for those of you that were in my class last year, you'll remember my highly technical, very mathematical math term. To switch it to an exponential, we do the circle thingy, all right? And the circle thingy is b to the x is a, and that's how I get from log to exponential. So b to the x equals a. So on the calculator, what base do we use for the log? 10. So that's called the common base. So we don't have to write 10 because that's the one we always know. But if it's not a 10, we have to specify it. So if I'm going to write each of these equations in exponential form, we're going to do the little circle thingy every single time. So I get 7 to the second equals 49. Is 7 squared 49? Yes. So 2 to the fifth is 32. All right, so finish filling those in. That's crazy. So once we go from log to exponential, can I go from exponential to log as well? So if this is the base, and it's the base here, so this is my base, so this would be log base 5, and then what's on the other side of the 25, on the other side of the equal sign, and then it equals 2. And you can double check if it's right by doing the circle thingy, right? 5 to the second is 25. I've got it right. So this one, log base 8 of 1 is 0. What's everything to the 0 power? 1. That's right, right? Yeah. Okay. So does it matter if it's a negative number? Log base 3 of 1 over 81 is negative 4. Okay? So that's from exponential to log and log to exponential. So this is all easy peasy, right? So when I look here, evaluating logs, so I want to set this equal to x and just do the little circle thingy. So 6 to the x equals 36. So it's 2, right? We know that's 2 because 6 squared is 36. So the reason that happens is because I have 6 to the x, and then 36 is 6 to the second power. So x equals 2. So that's why it's 2. All right? So if I did this, I would get 2 to the x is 128. So I want to know 2 to what power equals 128. Let's try 7. I'd go with 7 if I were you. Because I just told it to you. I would do 2 times 2 times 2 times 2 until I got to 128. How hard is that? Not hard. Okay, what about this one? It's going to have to be a negative. So 10 to the x is 1 over 100. So first of all, 10 to what power is 100? 2. 10 to the second power is 100. And how do I get it to the bottom of the fraction? Negative. That's all right. So, so for this one, I get 16 to the x equals 2. So let's start by 16 is 2 to what power? 2 to the 4. So I have 2 to the 4x equals 2 to the first power. So what's x equal to? Right. So x is 1/4. So 3 to the what power gives me 1 over 27. So first of all, 3 to what power is 27? 3 to the third, and then we want it negative to move it to the bottom. So here I have 8 to the x equals 1. What does x have to be? There's only one choice. 0, because everything to the 0 power is 1. So if I'm given this, is that a 5? Okay, so I have 5 to the x is 34. Can I get a common base with those? I can't. So this is what I can do, though. I can use the change of base formula because we can't find a number here. So the change of base formula is log of A over log of B. So for this one, I would take log of 34 over log of 5. And on your handy-dandy calculator, type that in, and what do you get? I got 2.1911. 4 decimal places, please. Okay, so do we need to do more of these? No, I didn't think so. Okay, so change of base. If you can't get a common base like these, you have to do change of base. All right? So the next one, so all of these we use log base 10, so that was the log. If I have base E, we're just going to call it ln, whoops, that's okay. So we're going to get ln of x. Yeah, we learned this last year. This is not new. None of this is new. We're going to have some new stuff, but just, it's coming. And then you want to go back to old stuff. Okay, so I want to write this in exponential form. So what's the base? What's the base here? Who just said 10? Joseph? What is the base? E. So I'm going to do e to the 4th is x. Little circle thing. What's the base here? So e to the x is 10. So if I want to write it in log form now, I'm going to have log, and its base e of 50 is x. Well, log of e, that's our ln. So log base e, that is your ln. So you do ln of x is 0.5. So if you look next to, I think is it the 7? It's either the 4 or the 7. Find the ln button. 4? So push ln of 64. What do you get? There you go. Was that hard? No, it was not. Okay, go to that super cute pink paper I gave you. Look at the paper. That's really cute. Cute, cute, cute. Everybody get on that. There we go. Okay, well, you got pink. Okay, so we're going to go over some basic properties. So b to what power would give me 0? 0. B to the first would give me b. So 6 to what power would equal 1? 4 to what power would equal 4? 1. All right, so logs follow the exponent rules. So logs follow the exponent rules. So if I'm multiplying x squared times x to the third, what do I do with my exponents? I add them. So I get x to the fifth. So when I multiply, I'm going to make that add. And this is what it's going to look like. Right? We separate it with the plus sign. So with that, we do two things. We condense and we expand. So condense means I want to take 2 and make it 1. So I have 2 here, so I'm going to write log base 3. And what do I change the plus sign to? Multiply. So I'm going to take 8 times 3x, and what does that give you? So that's your answer. If I want to expand, that means I have to have more than one term here. So I have ln. So will this factor? Thank you, Joseph. X minus 2 and x plus 1. So that'll factor. So what do I change the multiply to expand it? No, okay, I'm going faster. We're almost done. Okay. I got to talk fast before Joseph falls asleep. Noah's already been asleep. It's too late. I lost him again. So, but he's going to be wondering why he can't pass. That's going to be the problem. All right. So, when we divide, when I do x to the fifth over x to the second, what do I do with my degrees? Subtract. So I get x to the third. So this has to follow the same because it has to follow my exponent rule. So I'm dividing, so I have to subtract. So log of b minus, so we have to subtract the 2. So if I want to condense, that means I change the subtraction to division. So I get log, and condense means you only want one log, right? So I'm going to take 80 over 16, but 80 over 16 is 5, so I get log of 5. So if I want to expand, what do I change the division to? Subtraction. So I'm going to take log base 2 of x minus log base 2 of 5. Easy? Okay. The power property, I'm going to take this power and I just drop it to the front, from the top to the bottom. So I do n log base b of m. So when I condense, if it starts in the front, where do I move it back to? Back to the 9? Bless you. So I get ln of 9 to the third. So that's 9 times 9, which is 81, times 9 is 729. So to expand, if it starts on top, where does it go? To the front. So next, the change of base formula. That's what we were just doing, where we take the log of A divided by the log of B. So if I'm going to evaluate, I would take the log of 138 over the log of 5. And this one would be the log of 2 over the log of 14.